Hey team, we've done a little bit of congruence. Now we're going to look at similarity. So the difference is for similarity, if we want to prove that two figures are similar, we need to do one of two things. We need to either show that all the angles are the same in each figure, or we show that all the side lengths are in proportion. All right, now let's have a look at example 3 here. We don't have any sides, so we can only use the angles. So we're going to be using, we're going to be trying to show that the angles, let's start with A, right? We're going to show that the angles in ABC are equal to the angles in ADE, big triangle, little triangle. All right, let's begin. So what we can say first is that angle BAC is equal to angle DAE because they share it, right? So common angle. Now we want to show that I'll do it in green. These two angles are equal. All right, so we need to state that now it's pretty obvious they're equal because these are equal corresponding angles because we see BC and DE are parallel lines, right? So that's pretty simple. So we say angle ABC is equal to angle ADE, but we just need to provide our reason. Equal corresponding angles. Save some space for the next example. Alright, and then we can do the same thing here. Alright, notice how the order of the naming is the same for each triangle. So angle ACB is equal to angle AED, which means, well, the reason is the same, equal corresponding angles. Alright, therefore, triangle ABC and triangle ADE are similar. Okay, easy peasy. And we're going to do something very similar to triangle B. No pun intended. And alright, so in part B, I'll label these two angles here first. Now they're equal because they're vertically opposite, so let's say that. So angle ACB is equal to angle, get the order right, DCE. And we say because they're vertically opposite. And then we want to say, well, now we want to show that, I'll do green and blue again. This angle and this angle are equal, and we know they are because we have of the parallel lines, and these two are equal alternate angles. So angle ABC is equal to angle DEC. And we're going to say equal alternate angles. And now finally, we're going to do exactly the same thing for these two blue angles. So angle BAC is equal to angle oh, I just realized that I got the angle name wrong. So ABC is going to be equal to EDC. My bad. And now angle BAC is going to be equal to angle DEC with the same reason as above, equal alternate angles. A lot of writing here in these proofs. Okay, so again, that means triangle ABC and triangle DEC. I'm just using my words here. Similar. Cool. Simple as that. Let's move on. Example 4. Okay, so establish that a pair of triangles is similar and hence find x. Right, so now we've got some sides to deal with, so let's have a go, hey? We want to... Okay, first of all, we want to show that this little triangle and this big triangle are similar. Now, we don't have the third side of these triangles, so we're going to have to show that they're similar by first showing that their angles are all equal. Alright, so this little tip here is really useful. I'm going to label this ABC. Well, maybe I do this. So first thing I'm going to point out is that this triangle, well, this proof of similarity is going to be exactly the same as part A in example 3. Alright, so maybe I'll literally just ABC. I'll literally just copy this over. Saves us doing it again, right? So that establishes that these triangles are similar. What did I label? Like that. There we go. Okay. Now we need to find the value of x. So let's have a think about how we can do that. So in similar figures, all right, the sides are all in proportion. So if I go, if I take the two bases of these triangles and divide them, that means if I do 15 over 24, that should be equal to the... Actually, before I put in the numbers, I'll put in some... I'll name some lengths. So if I divide BC by DE, it should give me the same ratio as AB over AD. Right, see how I'm picking two corresponding sides of each triangle? Right, so these ratios should be equal. Now let's sub in some values. So that means if I go 15 divided by 24, I should get x over, now AD is going to be x plus 12. Alright, now let's do a bit of algebra here. So 15 will get multiplied by x plus 12, and 24 gets multiplied by x. So 15x plus, what's that? 180 equals 24x. So 180 equals 24 take 15 is 9x. X equals 20. And that's it. We're done. Alright, and you can sub these back into your ratio to check whether or not you do get the same scale factor. So we can quickly do that. So see, 15 over 24, if we simplify that, that equals 3/8. So we can do a little check. And then if we do x over x plus 12, now that gives us 20 over 32. Divide everything by, is there a common factor? No. Wait, sorry, it's not 3/8. It's 5/8. I divide by the wrong thing there. And divide by 4 is 5/8. So the scale factor for those sides are the same, which means our answer is correct. Alright, bit of work there, but let's do this last one here, example 5. An electric light post E is directly opposite a mailbox on the other side of a straight road. Taj walks 30 meters along the road. Hang on. Oh, okay, yeah, I'm trying to picture this bird's eye view diagram, or from a bird's eye view. Okay, so he walks from 30 meters road. Taj walks 30 meters along the road away from E. Oh, okay, so she started at E and he walked to T, righto. And then Canva is 4 meters away from the mailbox at point S. So EMS straight line, okay. He walks 6 meters parallel to the road in the opposite direction to Taj. Now T, M, and K are in a straight line. Alright. Find the width of the road. So basically we want EM. A lot of information here. First time I've looked at this one, so let's see how we go, hey? Alright, so we probably want to try to establish that these two triangles are similar before we do anything else. So let's go ahead and try to show that angles or sides. Alright, well, since we don't know all the sides, we have to try to show that all these angles are the same in both triangles. Okay, let's start with these two here. So if I go EMT angle EMT should be equal to angle SMK. Alright, and that's because they're vertically opposite. And then I'm going to show that, what else do we know about these triangles? Okay. See, directly opposite, E is directly opposite a mailbox along the road. E, M, and S are in Australia. I'm just trying to see whether we can justify that these are right angle triangles. If we can't, it doesn't matter. We don't need to, because we've been told that parallel to the road, have we been told that TE and SK are parallel? Parallel to the road, an electric chargeable along the road. Okay. Yep, so I guess we have been told that TE and SK are parallel lines. So what that means is angles, this angle and this angle are equal because they're alternate, and they're equal because of the parallel lines, and also these two are also alternate. So let's try to name those. In green, we got TEM is going to be equal to angle KSM. Alright, and then in blue, we have angle ETM, too many letters here, is going to be equal to SKM. Okay, now the reason for both of those is, I'm just going to write in big brackets, equal alternate angles. Alright. Now, we've established that these two angles are, these two triangles, hence, therefore we should probably just say that, triangle TEM and triangle, trying to get the order right, KSM are similar, which means their sides, all the corresponding sides of both triangles are in the same proportion. They have the same scale factor. So now we can use that to find x. Okay, so let's use some sides. So if I go TE, alright, so the side TE corresponds to the side KS. Have a look at that. So if I divide the two, I pick TE first because that's the larger number, and if I do 30 divided by 6, I get nice number 5. Alright, that's why I picked it. You could do this in any order. So TE over KS, so that should be in the same ratio as, maybe I should write, so TE over KS should equal, so let's start with our bigger triangle, EM over, so EM corresponds to SM. SM. There we go. So let's sub in some numbers. 30 on 6 should be equal to X on 4. So 120 should equal, so because 4 times 30, cross multiply. Save yourself some time. Okay. X should equal 20. Alright, now the key takeaway here is you need to show that your triangles have some sort of relationship, whether it's congruent or similar, alright, before you go ahead and try to find any unknowns. Okay.